Alright, so we're going to start with example 5 for the second half of 10.1. We're going to look at experimental probability. So experimental probability is based on repeated trials of a probability experiment. The number of trials is the number of times the probability experiment is performed. Each trial in which a favorable outcome occurs is called a success. The experimental probability can be found using the following. So number of successes over the number of trials. So it's pretty similar to what we did yesterday when we had what we want over the total. So it's just the number of successes over the amount of trials that we have. So example 5, each section of the spinner shown has the same area. The spinner was spun 20 times. The table shows the results. For which color is the experimental probability of stopping on the color the same as the theoretical probability? So first, let's find our theoretical probability. That's if we didn't perform any experiment and we ask ourselves, what are the odds that we land on the color yellow? What's the probability that we land on yellow? So the yellow, how many colors total do we have? 4. So 4, and yellow is just one color, so it would be 1 out of 4. So the probability of landing on yellow, the theoretical probability, is 1 out of 4. Do you think it would be different for blue? No, it would be the same thing. Same thing for red, same thing for green. So this is our theoretical probability. Theoretical probability is like, what are the odds? What are the odds that we land on yellow? That would be 1 out of 4. Now let's see our actual experimental probability is what we actually did. So these are results from the experiment. So for red, what was our number of successes that we actually landed on red? 5. So the probability of landing on red was 5 out of how many total spins did we have? 20. You could either count all these up and see that they add to 20, or it just says it was spun 20 times. So the probability that we landed on red was 5 out of 20. If we simplify this, what do we get? Simplify the fraction. 1/4. Let's find the probability of green. How many times did we actually land on green? 9. Out of how many? Out of 20. Can we simplify 9 out of 20? Nope. Let's find the probability of blue. How many times did we actually land on blue? 3. Out of how many? 20. Can we simplify 3 out of 20? Nope. And then lastly, let's find the probability of yellow. How many times did we land on yellow?
3.
Out of how many? 3 out of 20. So for which color is the experimental probability of stopping on the color the same as the theoretical probability? Red. Because our actual experimental probability was 1/4 and our theoretical probability was 1/4. All right, let's take a look at example 6. In the United States, a survey of 2,184 adults ages 18 and over found that 1,328 of them have at least one pet. The types of pets these adults have are shown in the figure. What is the probability that a pet-owning adult chosen at random has a dog? So the probability of the adult having a dog. How many adults have a dog? Looking at our chart.
916.
916. When we do our total number at the bottom, we have to read the question and see what group are we choosing from? What is our sample space? So it says, what is the probability that a pet-owning adult chosen at random has a dog? So how many pet-owning adults do we have?
1,328.
Perfect, 1,328. If the question said, what is the probability that an adult surveyed has a dog, then we would use this number here, because that's how many adults were surveyed. But you just have to read the question and see what group were you choosing from. What is your sample space? What is the decimal version of 916 over 1328? If we put this into our calculator, what do we get? So 0.689. So the probability that a pet-owning adult chosen at random has a dog is about 68.9%. Which, remember, for probability, you can leave your answer as a fraction, as long as it's simplified, which I think you could simplify this fraction. Yeah, you definitely can, because they're both even numbers. So this fraction in simplest form, or the decimal, or the percent. So you could leave your answer anyway, unless it specifically says what percent. All right, let's take a look at number 10. So it says in example 5, the one with the colors up top, for which color is the experimental probability of stopping on the color greater than the theoretical probability? Usually when it's something that we have to compare, so here it says greater, it's kind of hard to compare fractions, so we like to change it to decimals, because that way we can easily see which number is bigger than the other one. So what is 1/4 in a decimal? 0.25. What is 9 over 20 as a decimal? 0.45. What is 3 out of 20 as a decimal? 0.15. And then this one would also be 0.15. And our theoretical would be 0.25. So what does the question ask? For which color is the experimental probability of stopping on the color greater than the theoretical probability? Which color do you think? Green. Because green is 0.45, which is greater than 0.25. All right, number 11. In example 6, what is the probability that a pet-owning adult chosen at random owns a fish? So how many pet-owning adults have a fish? 146. So 146 is what we're looking at, so that goes on top. And then what's our total number of pet-owning adults? 1,328. We can simplify this fraction because they're both even numbers, so 2 is going to go in it for sure. So 146 divided by 2 will give us 73. And 1328 divided by 2 gives us 664. I don't think we can simplify that anymore, but what would our decimal version of this be? 0.1099. So if we change this to a percent, it would be about 11%, or we could say 10.99%. So all 3 of these would be sufficient answers.